Now, sometimes it's also important to know how long it takes you to travel a distance. We call that the average speed. That's the rate at which distance is traveled, and it's a scalar. And typically, we denote that V for speed. Don't ask me why. V stands for speed, and the line over it means that it's an average speed. And that's equal to the distance traveled. So when we have x written there, that's really the distance traveled divided by some amount of time. It's a scalar, and it's measured in units of meters per second. The way I remember speed is a scalar, s and s. If we look at this in a problem, our deer walked 1,300 meters east to a creek for a drink. Then he walked 500 meters west, then 300 meters west. What is his average speed if the entire trip took 600 seconds? Well, average speed was the total distance traveled, which we said was 2,100 meters in a time of 600 seconds, so the average speed was 3.5 meters per second. And since average speed is a vector, we don't need, is a scalar, average speed is a scalar, we don't need to include a direction. It's a magnitude only. Average velocity, on the other hand, does have a direction. It is a vector, and it's the rate at which displacement changes. So we said displacement we could write as x minus x initial, your final position minus your initial position, or we can also call that delta x. So average velocity, which is oftentimes shown with the exact same symbol, v for velocity with a line over it, so v can stand for speed or velocity, is delta x over t, the rate of change of your position or your displacement with respect to time. It's also measured in units of meters per second, and you can remember it's a vector. V velocity is a v vector. So, same problem again. Now our deer walks 1,300 meters east, then 500 west, then 300 west. What's the deer's average velocity if the entire trip took 600 seconds? Well, average velocity was our change in position, or our displacement over time, which we said was 500 meters east over 600 seconds, or 0.833 meters per second. And since it's a vector, we have to give it a direction. East. 0.833 meters per second east. Let's see if we can't put this all together as we talk about a problem involving our friend Chuck the hungry squirrel. Chuck travels 4 meters east and then 3 meters north in a quest to find a lovely little acorn. As he's on that quest, we want to know his distance traveled. Well, distance traveled is pretty straightforward. If he went 4 east and 3 north, he must have traveled a total distance of 7 meters. What's his displacement? Well, displacement then is the straight line distance from where you start to where you stop. That looks like a 3-4-5 triangle. Or if you didn't remember the 3-4-5 rule, you could use the Pythagorean theorem to find out that the length of the hypotenuse is 5 meters. So Chuck's displacement, x minus x naught, which is a vector, displacement, must be 5 meters northeast. Chuck's average speed is distance traveled divided by time, or 7 meters in 20 seconds is 0.35 meters per second. And if we want Chuck's average velocity is the rate of change of displacement, the total displacement or position change divided by time. Well, that was 5 meters in 20 seconds, or 0.25 meters per second. And since velocity is a vector, it again needs a direction, northeast. So 0.25 meters per second northeast is Chuck's average velocity. Some very subtle differences in these different quantities in physics. And the symbology changes quite a bit depending on which book you're reading, so I'm not going to get too hung up on it for now. As long as you understand the concept, the specifics, sometimes the symbols for these change from course to course.